You remember I had these of yours? Those are mine. I'm like, where's your team glue? Give it back. That's why I had to borrow hers. I use it for
Okay. Good morning, everybody.
Good morning.
I hope you guys doing okay. It's cooler outside, right?
Yes.
I'm kind of with the junkie. I just always try to see what's going on. So you guys feeling okay? No cold?
No.
Wonderful.
Little bit.
Little bit? Should be better. Take some ginger tea and honey.
I have green tea.
Green tea? Mm-hmm. No.
That doesn't work.
Nope, it's not gonna work. Ginger tea and honey.
Honey?
Yes. Okay. So chapter 2 today. It's gonna be first lecture on chapter 2. We'll be learning a lot of concepts that you need throughout the semester. It is full of concept for general chemistry, and I think we'll take one more class to complete this chapter, not one class. And let's begin. We have atoms, molecules, and ions. As you see the names, these actually make compound, chemical reaction. So in addition to learning atomic theory, ions, molecule, we'll be learning chemical reactions as well. First thing, I'd like to say that at the beginning of the chapter, a lot of materials is kind of history, how the theories have been developed, you know. I will not be focusing that part. To me, that is less important. We'd rather would be focusing on learning chemistry of atoms, molecules, and chemical reactions. So after this chapter, we'll be able to understand atomic theory, structure of atoms, isotope, ions, molecules, nomenclature of chemical compound, and chemical equation, and how to balance it out. Okay, let's begin. As I said that we'll be starting from discovery of Democritus about the atom. First, let me ask you a question. What is atom?
The smallest particle.
Smallest particle of matter. Exactly. Smallest particle of matter, or smallest building block of a matter. Okay. So people have been working throughout the centuries to know what is the atom. The atom we know of today that was known always. So Democritus was the one who first said the valid definition of atom. He said that atom is the smallest indivisible particle. It cannot be divided anymore, and it cannot be destructed anymore. You can break it up because this is not the smallest particle of this metal. But atom is the smallest particle. It's not divisible anymore. It's not destructible anymore. That's what Democritus said. That time people didn't know what is atom. People didn't know what he's talking about. Even he doesn't know by himself what he's talking about. Maybe he laughed at himself. Because it's a new concept. Later on, Aristotle came. Aristotle said that atom is not that divisible or indivisible. He said something totally new. He said that atom is made of air, fire, earth, and water. But that idea did not exist long. Dalton came. He's an English scientist. He came up with a valid and very empirical definition of atom. He said that a compound made of atoms, and atoms are combined together make a compound. So he actually supporting the idea of Democritus, that atom is smallest particle and this is not divisible anymore. He's supporting Democritus, and he also said that what is chemical reactions, what is compound, more theories, details, understanding of basic of atoms and molecules and chemical reaction. He said that chemical reaction is a rearrangement of atoms in different molecules. And based on his theory, we get the empirical definition of atom, molecule, and chemical reaction. So we can understand these four theories based on his discovery. So first of all, law of conservation, law of definite proportion, law of multiple proportion, atomic theory of matter. So we'll be learning all of them. Let's go first one, which is law of conservation of mass based on Dalton's theory. So it means that no matter how you look at your product, no matter how it does look like, this product nothing but rearrangement of the reactants. These reactants are rearranged to each other, that making a product. It also says that this number of atoms in reactants is going to be same number of atoms in product. Also says that the mass of reactant, total mass of reactants is going to be equal to the total mass of product. So if we write the chemical reactions, sodium plus chlorine, that makes sodium chloride. So this sodium chloride, mass of sodium chloride, product of sodium chloride mass is equal to mass of both reactants. Number of atoms was 2 atoms, you see 2 atoms. It was 2 chlorine, you see this is 2 chlorine because prefix 2 means 2 chlorine. So product and reactants are same. Actually, this is kind of repeating for you from the other chapter, earlier chapter, right? Mm-hmm. We talked about that law of definite proportion earlier. So second theory is law of definite proportion. Law of definite proportion is when a compound is formed, they maintain specific proportion. For instance, this sodium chloride. For instance, you have a water molecule. This water molecule maintains specific proportion, 2 to 1. 2 hydrogen combining to 1 oxygen. You see? That's how the combination is. And this is always going to be constant, same. You take this water from the pond, from the street, you make in the lab or industrial byproduct as a water. So all water, or you take water from the South Africa, all water will be same combination. It have to combine as a 2H and 1. That's called law of definite proportion. For instance, other compound, copper carbonate. Whatever you take it from, any source you take it from, they maintain specific ratio, which is calcium, copper carbonate. So CuCO3. This copper carbonate have a 1 copper, 1 carbon, and 3 oxygen. This ratio is going to be always same from you collect it from any resources. The third law is law of multiple proportion. This law little bit critical. Law of multiple proportion. In law of multiple proportion, you always have 2 atoms combined, making multiple compound. And one of these 2 atoms will be always integer ratio with 1 gram of other atom in those molecules. For example, if A and B combining together forming AB1, AB2, AB3. See? So in here, if A is 1 gram and B is 1, 2, and 3. That means if this is the 1 gram combined with this B, and B ratio would be always, you see, 1, 2, and 3. That's what it says. For instance, this is couple of molecules. Carbon, oxygen form carbon monoxide and carbon dioxide. HO and H2O2, right? They're forming water and hydrogen peroxide. NO and 2O. They're making nitric oxide, nitrogen dioxide. You see, this is like simple, but this is if I blow some N2O, you're all gonna be smiling because it's called laughing gas. Have you seen that before? Have you heard it? That's laughing gas?
Yes.
Yes, laughing gas. You know H2O2? What is H2O2? Hydrogen peroxide. Do you use that sometimes? What? For antiseptic, right? So, and this is water. You see, this is life savior. This is like killer, right? It's antiseptic, it's a poison. You know the story, right? One physicist and one chemist. They both together went to the bar. Maybe the Friday night, maybe. And chemist saying that, give me H2O. And the physicist say, he doesn't know what is H2O mean. He said, give me H2O2. Guess what happened?
Give me H2O2.
And ended up he died. Because he got H2O2. That's the poison. The other one got it, but chemist was fine because he knows H2O and H2O2. So, yes, it makes a lot of difference with a structure. Water, H2O2. This is simple nitric oxide, but this is laughing. You're gonna be laughing, right? We should keep sometimes, right? If you need to laugh, you don't feel to laugh, then you can just put yourself. Anyway, it might not be safe. I don't know the details of the how it affecting our body, but I just know this is laughing gas. Carbon dioxide and carbon monoxide, right? Both are toxic. Carbon dioxide is a pollutant. You know, we breathe out carbon dioxide, and carbon monoxide is a poisonous gas. We don't want that. Anyway, that's not our goal of learning in this section. Our goal is understand that two atoms combine together forming multiple molecule, and one of them is 1 gram, the other always maintain smallest ratio. Let's give one example about that. For instance, carbon and oxygen forming carbon monoxide and carbon dioxide. So if you look at the periodic table, everybody have the periodic table, right? You have periodic table.
Oh yes, right.
Okay. If anybody needs more, let me know. I have a couple of more tables. Okay. So the mass of atom is the bottom of the symbol, right? In the periodic table is full of all atoms, right?
Yes.
So you see, in the top of the atom is their atomic number or proton number, and the bottom is the mass. So based on that, if you look at the carbon is 12, right? Is 12. 12. Carbon mass is 12, right? You see that. How about the oxygen mass? 16. That means you see here is 16 oxygen. Or O2 means how much in here? 32 because O2. So if you see that, if you make it 1 gram of one of them, make it 1 gram, how? By dividing 12, by dividing 12. So 1 gram, so that means 1 gram of one of them, if you see that they are 16 and 32. If you make the ratio, how you make the ratio? By dividing smaller one. Dividing 16, then you can get the ratio which is 1 to 2. You see how it works? If you have 2 atoms combining more than one of them have a 1 gram, other one will be smallest integer ratio. That's what it says. Yes, sir.
Sorry. Hello.
Yes, sir.
When you finish, come to talk to me a moment, please.
Definitely.
Yes, we have to have something
Sure.
about the lab.
Of course. Okay.
Thank you.
Thank you. So let me see your concept. Okay. Try to get the answer of this question. You got the answer? Take time. Take 1 minute. So what is the answer? D. Wonderful. Good job. And let's move on about the ions, atoms, elements. So we talked about the details about what is atoms, elements, and the compounds and chemical reactions. Atom is the smallest building blocks of matter. Element is a type of composed of only single types of atom, right? So all the name you see in the periodic table, all are called atoms, right? So element is when you have single atom in a matter, that's called element, right? And compound. What is compound? 2 or more atoms combined together, chemically combined, right? Together form a compound. What is chemical reaction? Rearrangement of atoms, right?
Yes.
Wonderful. And we saw the anatomy of chemical reaction in the first lecture. So, okay, let me ask you, which one is carbon dioxide in here? Just to see, I want you to visualize how the compound look like. C is carbon dioxide.
Is it E?
E, wonderful. Who said that? Good. E is a carbon dioxide, right? That's how the atom molecules look like with the atoms. Yes. Now we'll go to how the atom are structured with their subparticle. We learned that atom is not divisible, but doesn't mean that it doesn't have this subparticle. Yes, it does. It has subparticle. That's how atom made of. So atom made of with some few subparticles. They are called electron, proton, and neutron. Electron, proton, and neutron. So about the atom, there are two most important theory. I like you to guys know. First one is first Thomson model. Thomson said that electrons and proton are arranged in an atom like a plum pudding. He didn't know that nucleus, center, location, circulation, what is atom, what is proton, what is neutron. He didn't know that. He just said that they're like plum and pudding, plum pudding model, because electrons and atoms are in a just bunch of electron, bunch of atom, bunch of electron, bunch of neutron and proton are like a plum and pudding. He did not specify how they are located, where they're located, and how they are circulating, how they are located, how they are arranged. So, but Ernest Rutherford, he took this idea of Thomson in a very specific and very clear understanding level of atom. So he specified what is the electron, what is the proton, what is the nucleus. Before that, we did not know about nucleus and proton. So he did some experiment which clearly explained what is the nucleus, what is the proton is. So let's see what is the experiment look like. So in his experiment, he took a gold tin foil. So, and he passed, he fired alpha particle. Alpha particle is positive charged. So he fired alpha particle. Suppose it's alpha particle. Alpha particle. So he fired alpha particle. I don't want to go how he produced alpha particle. I just want to tell you that he produced somehow. And he passed alpha particle through a thin aluminum foil. And in thin aluminum foil, and he found out that most of the particle pass through the foil. Most of them pass through the foil. But he was shocked that some particle randomly, for instance this one came this way, bounced back in randomly. This one came back straight back. This one bounced back maybe that way. So he found that almost all of them passed through the particle he passed through a aluminum to a gold foil, thin gold foil, and few of them randomly bounced back. And he was shocked about that. He said, how come? And he understood that since alpha particles are positive charge, there is definitely something in the center which also positive part, which also positive particle, because positive and positive they reflected, and he found out that it's in the center and tiny, very tiny space in the center of atom, which is similar charge of alpha particle. That means he said that yes, so there is a nucleus which is in the center of atom. He said that there is some particle which is proton in the center, which is reflecting the alpha particle that he fired. So that shows two things. First thing is atom have a center which we call nucleus. We also can get that there is some particle in the center which is positive charge. That's called proton. Clear? Mm-hmm. That's two things he discovered with this gold foil experiment. As you see there, alpha particle, he emitter from here and few of them bounce back and few passes, you see. So some deflected, some came back, and some passes through. That means every atom have a center which is nucleus. Okay. And then what is electron? Electron are occupying for the whole space. Because alpha particle is positive, it doesn't have any reflection with a positive and negative electron. It only reflecting with a proton which is positive, not with the electron which is occupying the whole space of the atom. So now question is, can you imagine how atom look like? Center is nucleus, proton, which also have a neutron. And neutron doesn't have any charge. So it doesn't affect with anything. But proton have a positive charge. So can you imagine how atomic size is? Very tiny or super tiny or of course it's super tiny, right? So let me give you an analogy how you can imagine atomic size is. For instance, you hold here a basketball in this, sitting in the Houston city. And the periphery, the edge of the atom would be maybe end of the Pacific Ocean, like Japan. So edge of the atom would be Japan, and you're holding a simple basketball in Houston city. So this basketball is a nucleus, and the edge of the atom is Japan. You see how big atom is and how tiny nucleus is. And that nucleus have a proton and neutron. And electrons are circulating in the whole space, atom whole space. Electrons are circulating in the whole space, so the tiny particle is a nucleus. You see how tiny nucleus is, and that have proton and neutron. Look at that. It has a proton positive charge, it has a neutron which doesn't have any charge. It has electron which is circulating around neutron and proton, circulating around the nucleus. Yes? That's how the atom look like. And as I said, positive neutral particle, negative charge. And so let's see, for instance, I have here a atom which is color is a neutron, and the green one, the blue one is a neutron, the red one is a proton. So what is the proton number? Proton number is how many proton you have in the nucleus. That's the proton number. And what is atomic number, which we call use as a Z, atomic number. What is the proton number? That's actually the atomic number. Number of proton is actually atomic number of atom. Okay, so look at that. This one have three proton in the nucleus, right? So let me ask you a question. So is referring to which atom? Lithium, which have 3 atomic number. And how many proton, how many neutron you have in this lithium? 4. That means lithium, that means neutron number not necessarily always equal to proton number. Yes, many times, almost all the time, maximum case or most of the atoms, neutron number and proton number is same. But not necessarily always neutron and proton is same. But even though it's not same, they are close to. Neutron is a little bit more than proton number. And the mass is additional combination of atom and neutron. If you add up mass number, this is the atomic number. Yes. For instance, helium, it will be 2, atomic number or proton number, and then mass number on the top left. So, nuclear symbol of potassium. Potassium, if you look at in the periodic table, potassium have 19 proton, right? So that means the atomic number is 19. And mass number of potassium is 39. So how would you write it? It would be, so total is 19 plus 20. What is the neutron number for potassium? 20. Because 20 mass, so mass is proton plus neutron. So other part is neutron, which is 20. You'd write 39, 19. And atomic symbol, you write as a capital letter, uppercase. Any question with that?
No, there's a way to remember it. It's like 8 man.
What is
It's
it?
like 8 man, 8 PE.